All right, so we have a product specification that we're going to be starting from to build a loyalty points system with the BSV distributed application stack. So the app is going to let a user click a big button that's going to represent engagement with a particular brand, let's say. They're going to create a transaction which gives themselves loyalty points, and they're going to pass that transaction to an overlay, and the overlay will accept it only if they've made an associated payment of 7 Satoshis to like a known address which is associated with this brand. I'm not that interested in game mechanics and things like that. We'll focus on like, how do you make these tokens? How do you validate them with an overlay? Like, how is that stuff supposed to work? So hopefully this is a good premise to demonstrate how you do that stuff with the open source distributed application stack that we've been working on. So a simple spec document based prompt to begin on. Just give it some instructions to separate out the functional code so that we can keep that on screen. And that's the part that I want to develop as part of this video without being in the weeds of a React app. While that's working away, let's take a look at the Docker Compose file here. We have some basic requirements to spin up an overlay, one of them being in the MySQL database here, MongoDB, and then we'll have the loyalty overlay, which makes use of those databases. So these are just placeholders for now. Again, just copied across from the demo tokens example. This is what we do when an output's been admitted. We decode some push drop. Push drop is just a class from the TypeScript SDK, implements the script template, and it allows us, it adds this one static decode, which grabs data. The concept of the locking script is that you have arbitrary push data that then just gets dropped off the stack. So the first thing we want to do is make use of the wallet client here. I can see it's already been passed in, so fantastic. So all we want to do with that is create action. And the description is we're creating loyalty tokens. The outputs are the loyalty tokens themselves. Yeah, that'll do. And then we need an output description, token output, loyalty tokens, and the actual payment. So placeholder locking script, 7 Satoshis, server payment, exactly. Okay, so that should be all we need here. Okay, so let's actually import push drop. Is a new push drop, and we're passing in the wallet. Again, we have to take that from the BSV/SDK. Token locking script is going to be a push drop lock. One of the things we're going to need to encode is how many tokens. So let's just say fields is going to be an array of numbers. The first one is just going to be token count. But what we're going to do is make a writer. So it's a var num we're writing, and it's not to buffer, it's actually to array. I think that's the only detail we need because we're not going to use multiple token IDs or anything like that. It'll all just be the one. This overlay will be dedicated to this loyalty token. So server payment address is what we're passing in to a locking script, which we're going to grab. Page public key hash is a standard locking script. So the server is going to be able to unlock that so long as they use the same details here. So we have the token script, the payment script, and then what we want to do, I mean, it's all fine and well if the user just makes this transaction. What makes it valid in terms of loyalty tokens to spend later is going to be the fact that the tokens exist within the context of this overlay. So how do we do that? We want to hit a submit endpoint on our own overlay. Overlay is going to go on 8083. Yep. And then the endpoint, I believe, is just submit. So we need to set the basket loyalty tokens. So this is going to add to a basket, which I can then look up. I want to relinquish this output if it's rejected. So technically this will create a transaction that's going to broadcast it. It'll exist. The overlay may reject it. And then you've still got these tokens. So when you're looking at your listing, your outputs in the loyalty basket, you will still see them even if they're invalid, which, you know, is obviously suboptimal because we've got custom instructions. What we'll maybe do for the lookup of loyalty tokens in the app, we've got these 21 loyalty tokens pending. And when we look up what our balance is, what we can do is maybe use the overlay rather than using our own basket, and only use our own basket to grab the details necessary to unlock them. So the loyalty tokens that are in here we can grab the derivation instructions from our own basket. I think that should work. So now we need to connect up the balance. So when we come back here, so on first load, loyalty tokens. So on first load, the loyalty token balance should be queried by using the get token balance method in the token service TS file. Great. So fetch balance, get token balance, print balance, great. So now hopefully, it doesn't work for some reason. Decoding the push drop here is almost certainly failing. Okay, so we're going to change strategy slightly. So we're not going to be able to look it up by identity key because that will be revealing private information to a public lookup. So we can either find all, or probably better, we look up our own basket and then we find by output. Get list outputs from loyalty. Okay, we got that, and then we're going to pull out stuff based on outputs. Okay, so this is how we'll actually look stuff up. Get token balance needs to happen first. We're listing outputs, and we want outputs from result basket just to pull out the stuff. Okay, it's first things first. If the count is less than the tokens to spend, that shouldn't be possible, but let's just say then the tokens to spend equals count, just all of them. Nice. So now we're going to create action. The response is going to be a signable transaction because we haven't signed all the inputs. Okay, so that, and we're going to sign inputs. We need to create a spend. So then that gets converted to hex and sent. And then the final response is something that looks much more useful. That should be it. Oh, purchase is complete. How wonderful. So we have the token service working now. Purchases working. Okay, so now it's all running again. I'm going to press my loyalty button. Create a bunch of new tokens, 61 tokens being created. Ooh, a 6% off when I go to the shop. Okay, and I'll get a couple of items here, 42,045 with my discount. Purchase is complete, and I should have less than 61 tokens when I refresh. Excellent. Seems to be working now. Can I still use my discount? Yes. So we have loyalty token system fully developed. This code will be made available for everyone to take a look. The link will be under this video, so you can take a look at this source code and change and adapt it for your own needs. Thanks so much for listening to me develop. Thanks for coding along if you were following along with the code, and we'll see you on the next one. Cheers.